Okay, so this video is about doing a more advanced behavior for the flip-up targets in Elvira and the Party Monsters. So it will be only by script, and we will begin, you remember, if I take it back, we will begin to do some physical behavior on both the front target and the flip-up target. In the Unity sense, so we will add what is a hinge joint here in Unity. So this is the documentation, the script documentation page for it, and we will add to our object. So first let's rename here the script, the class of the script, because it's not as simple as it is right now. And don't forget to change also the name on the add component. We don't want to change it because the slot won't change right now. And first let's change the flip-up state. So now we won't transform it by hand, and we will do something else later. So for now, let's remove all of this. Maybe we won't need it anymore at all, so we will see it later for the switch activations. So the goal is to set a hinge for each object, one anchored here and one anchored here. So as it happens, it's the 0, 0 of each 3D object I made in another program. So we could have used gate behavior, but let's do it by hand, so you will see how it works. So we will modify the setup here. We will keep the slot number, and we will keep the looking for the flip-up object, as if you remember, this is applied on the front target. And let's do, so we will need a new function. We will create a function, a handle function, a tool function, a utility function, and it will be called hinge me an object. So hinge object, and it will take a game object as a parameter, game object O. Okay, so what we will do with it, we want to add a hinge, so a hinge component, but for it to work correctly, it will need some collider, because all the physics will be applied to a rigid bodies, which will be added when we will add the hinge object. But for it to compute correctly all the forces and so on, it will need a collider. So there is a collider on the front target because we added it inside the FPM editor, but there is not on this one. So let's set a test. If o.get component of a collider, so this should return null if there is no collider, and so if it is null, we want to create some. So let's add a component, which will be, for this one, actually a mesh collider. As mesh collider inherits from a collider, it will be returned if it was there. So it will be for the flip-up target, and we will do it at a mesh collider. Alright, so now that we have a collider, we can, sorry about that, we can set up and add our object. So it will be a hinge joint here, and it's something that we have to add. So add component, and add a component of the type hinge joint. So it's better doing with the the template way to do it, because it returned directly the good object type. And right now we have our hinge joint, and the first thing we have to do is the joint. We want to set the anchor at 0, 0, 0 of the object. It's in local. It's not interlocal. Let me show you this. So it's an anchor for the joint, and this is the vector free. So it will be vector free, and actually it's a vector free 0. Okay, and don't forget to code it. So we want to code it for the game object, as it's for the front target, and we want to do it also for the flipup we found it. Actually, if flipup. This will prevent a crash if flipup target is not found. Okay, let me check things, and so it should work right now. So let's take a look at what it looks like inside Unity. And also, again, let me just pause it for you. Okay, so the game is launched, and let's zoom on our targets, and it seems that it's correct behavior. I mean, it seems to be hinged on 0, 0 here. Let's send the ball on there to see what happens. Okay, so it's spinning around the good axis, and let's send the ball from the back. Well, it's okay. So as you can see, physics is correct. You have the collision with the ball, but, and it's a limitation right now, the collision doesn't occur between both targets. So this is something we will see later on this video to handle that. But the behavior is correct, so we will have to add limits. As you can see here, we can set limits on this joint for it to prevent it from spinning around all the 360 degrees around it. But before, let's just show you something that's inherent to Future Pinball. I will zoom again, and I will use the nudge buttons, and you will see that, as you can see, objects are not correctly following the table because it's the way the nudge is implemented. So we have to change just a little bit our script. That's what we will do right now. Okay, so all right, so now to do it, we will create a new object, a fake object, which will have also a rigid body, but this rigid body will be in kinematic mode. That means it will not be modified by the physics of Unity, but we will be able to anchor our hinge directly on this object. So let's do it. We will create a new game object. So let's call it solid. Here's a new game object, and we can pass the name. So let's say that it will have the name of our object, and it will be underscore anchor. So this will be the name of our object. So now we will add a component to this object, and this will be a rigid body. Okay, and we will get directly this rigid body, so this will be the anchor body. All right. Before doing that, we will place the solid in the same position as the current one. So to do that, we will get the solid transform. Alright, and we will set its position to the position of the object we want to anchor it. Alright, so okay, what's the problem here? No, it's correct. Also, don't forget to change the orientation too. So this is the local rotation. So now our new object is put at the same place in the world space as game object O. And now what we want to do is first to insert in the hierarchy this object to the father of translation object, so of the O object. So to do that, we have to set the solid.transform.parent, and its parent will be the parent of the object currently. And the last things to do is to, as we want to insert it inside the hierarchy, we want the parent of the transform to be the current object. So now in the object hierarchy we will have first parent. So as for flipup targets, it should be an ornament. The ornament will have a sound called the name of our object underscore anchor, and inside this one we'll have a child, and the child will be the object, the current object. So right now we create an anchor body to add a rigid body to this solid object, and this body, it's important to do it. We have to set it as, if you is kinematic, you can look inside the documentation here, and it's on rigid body. Okay, and as you can see, the is kinematic, it's whether the physics affects the rigid body, and we don't want the physics to affect it because we just want the nudge system to do it using its own way. So we have to set it to true. By default it's to false. Okay, so now we have both the objects and the hinge joint that we added to our object. We have to anchor on 0, but we also have to set that the connected body is the body we add to the anchor object. Okay, so this should work. Let's try it. So now the goal is to be able to nudge without the problems we had before that. So let's launch the table. Okay, so there was a problem here. It's just a mistake I made here. It's that I forgot to call the transform of the solid. Oh, sorry for that. Sorry about that. So let's launch it again. Okay, so let's zoom on it. Right, and now let's nudge. So as you can see now, it's correctly behaving and it seems anchored to the bracket. So now we can set up the limits of the hinges. Okay, to set up the angle limits for the hinge joint, we will go to the documentation of hinge joint here, and as we can see here, there is a variable called limits, and a variable called use limits. If you are used to Unity, this is display into the explorer of the object, into the inspector, and so we will set it up. So let's go back to our script, and in our in-joint object we will add two variables. So the first will be the min angle, and the second one will be the max angle, and this is what we will use to set up the limits. So after having our in joints here, we have to set up limits, and limits is a, if I remember correctly, values. Here we will set min equals min angle, and max equals max angle. Now, if I remember correctly, this won't work because we have to copy the G limits into a local variable called join limits. And now we can set it up here. So g.l and g.l, min angle, max angle, and don't forget to set it up back. So limits equal gl. And one thing is missing is the is to set it to set the joint use limits, and we have to set it to true for it to be used. So this should work. And the last thing is to call our hinge objects here. So for the front target, as the zero angle is the angle of the base pose, so this is the one that we inherited, and it's going to, we don't want it to go too far up here, so I think 25 degrees, 25 degrees should be just fine. And for the flip up here, so 0 is this pose, as it's the object we imported, and it's the other limit is in the other way around, so it's a -1, and here it looks like maybe, I don't know, 100, maybe a little bit more, 110, and so the max limit will be 0, this one, so it will be at the max limit. Okay, and this should be just great. Don't forget that these are floats. I save my script, and that should work. Let's launch the table. Okay, so let's go and look at what it's. Okay, so these are at the 0 we set, and if I throw a ball using the debug shot, we can see that the target is spinning, and it's just a great value for the object. And as you can see, collisions between front target and this one is now working, but that's something we will set it up just after that. And let's try the upper one. So as you could see, I threw a ball and it wasn't strong enough to lift it up, and now it is. We can see also that the angle here is a little bit low. We will increase it, but actually it's great because there we really can see Elvira, but we will increase it. So let's throw a ball on it to come back. Okay. So as I said, if I throw on the front target, there is no physics for the collision, and we have to set it by script. There is no physics between the two targets. Collision occurs only between ball and targets, and that's what we will set up just after setting the limits of the flip-ups, maybe to 130. Yeah. Okay. And we will now just do the interaction between this one and this one. So to do that, we will have to check if the hinge joint is up or down, so if the flip-up target is up or down. To do it, we will check if the angle is near the limits, and so we will need some margin. So let's define the margin. It will be a float called margin, and let's say right now it will be of 25 degrees. So it means that we will be down if the current angle of the target is between 0 and the margin, for example. So to do that, we will define a function, a utility function called isUp. And another one called isDown. So this one will be to check if the target is flipped up with some given margin, and it's the same for the down, which should be the default state. So let's do it. First, check if the object called mFlipup has been defined. If it's not, then return false. Next, grab the hinge joint object. So we use it because in the next version we could have used, flipup.hinge joint directly, but this shortcut will be disabled for Unity 5. So let's do it the right way, and it's this one. And of course, whoops, sorry. Check again if the hinge joint has been set up for this object. And now we will return a condition. So the condition is, let's take it, joint dot limits dot min minus the current hinge angle, so it's g dot angle. You can check that into the documentation here. Angle for a hinge joint, it's the current angle in degree relative to the rest position. And we will have to take the absolute value of this, just in case it's below the limits for some reason, which should not happen, but let's do it. And of course, if the mean angle is bigger than the max angle, we have to use the absolute value, and we will have to check if this is inferior to the margin we set up before. Then we return true because the flip target is up. And let's copy that for the isDown. But here, actually the angle minus the max limits. So these two functions, this first function should return true if it's up within a given margin, and down if the flip-up target is up within a given margin. And first let's do some just a debug function. We will redefine the update function for any given mono behavior, and in this one we will first check again if the flip-up is set up. So if no, we will return false. And now let's do it. So if it's up, then this is the thing. So let's take flip up, so the object, then take the renderer of the object, then the material of the renderer, and then set the color to red. So this line, with this line, update is called for every render loop. So before rendering, this function will be updated, will be called, and if it's up, the material will tint the flip-up target in red. So if it's not, and if it is down, the target should be tint in, let's say, green. And do not forget, if it's in between, we'll set by the default white color. So let's try it. Oh, this is a stupid mistake here. I had to this is copy paste mistake. This function is not typed, so let's try again. Alright, so let's look at it. So both targets are tinted in green, so it seems to work correctly because we are down right now, in the down state. And then let's try again, and it's tinted in red when it's up. This one too. Let's do it on the other side, and it's working quite correctly right now. This is what we wanted, but of course the interaction with this one is not defined yet, and we have to trigger the switches of the target of this one. So let's do it right now. Okay, so for the interaction between the two targets, we will set it up there. So we will create a utility function, another one, and this one will be apply force. Okay, apply force to the flip-up, target, and we will take just a float for the amount of the force. So well, let's call it like that. So to do it, we will have to take first we will check if the hinge object has been set up, the flip-up object. So flip-up, okay. Now for this object we will take the rigid body, right, and we will apply a force on it. So the function is add force, and it will apply the force on the gravity center of the object, of the rigid body, and on this one it will be around here. The best thing would have to be use add force at position and to set up this position, but for this we won't need it really. So we will add the force, and the force is not is a vector, it's not a nominal force, so we will use the default up vector, which we multiply by the force we want to set up on it. Right. So this should only apply a force, and the physics engine will take care of the rest. And when we will have to call it, we will have to call it there. So this, when the collision occurs on the ball, we will set the force to the flip-up target to simulate the interaction between both the targets. So let's do it, and we won't need the flip-up state right now, and we won't need also for the kickback, and we will need to have a force value. To do that, we could of course set a force, right, and we will use the relative force of the collision. Why will we do it? It's because we don't want the flip-up target to go fast if the ball hit the first target slowly. So we will use here the collision object, which we call the other on this one, and it has a relative velocity field, remember. So we will use this one, and if the ball hit the target when slowly, this relative velocity will be slow. Actually it's a vector, so we'll have to use the magnitude of the vector because we don't care about the orientation, and we will multiply by some given value, and it's completely empiric here. So this would give us a force. We can just log it for now. We will use log error for it to be displayed on the debug screen, and just display the force, right? We have to take care that we want to apply the force only if the flip-up here is down. Why to do so? Because if we apply it when it's moving, it should not occur. So we have to do a test before. If is down, actually if it's not down, then return, because we don't want to apply a force if it's not down. So we will set up the force, and we will apply a force. Flip target using the force we just gave it. So that should work. But how to set up this function, this value? Maybe it's too high, maybe it's too low, we don't know. So here is the thing. When I launched the Unit3D Pinball, in table option there can be some table specific options which can be used inside the interface. And to do that, we use what we call table specifics. I will open the Adams family script because it uses this kind of values, and this is how it's done with the script. We declare a static class. I will copy this, right? Actually, I will launch for you to see what I mean. I will launch the Adams family, and that way you will see what I'm talking about. Okay, and now when I use the table options, here you can see there are table specifics, and if you look closer, you have the Optimus flasher, if it's a boolean, we have here a checkbox, and for the values we have here an input box, and it's exactly the same name as in the class. We use introspection to do that, and of course we can use it to set up things for tuning or debug specifically for this table. So I will quit. And how will we do it for Elvira and the party monster? Well, you have to copy the static class or declare a static class. You can do it over the main table script. We will rename it because it's for Elvira table. And we only need one static float, which have to be public, and we will call it maybe a force multiplier. We will remove it at the end, so we don't care how it is called, but and we have to set up a default value, so the 51 here. And this way we can use it right in here in Elvira specifics dot force multiplier. So this will take this value, and for it to be accessible inside Unit Pinball, let's go back to the Adams family. You have to write this line down here. It's called table options, set specifics, and to do that, actually it's right under the global sound in the default sound, and here we have to use the same the exact name we used, so copy it back. This is the first is the name of the class, the static class, and here is a special callback if we want to know at exact point when the values have been changed. We won't need it, so you can remove it, it's an optional one, and this should work right now, so let's do it. I launched the table. Okay, and we will leave the development console. And so now if I zoom on it, let's launch a ball slowly. So here you have the relative velocity we set up here, and as we said, the force has been kicked up. So I will try again on this one with a smaller. Okay, it seems that the multiplier is a bit high there. So first we have to set back the flip-up targets for the test. Okay. Sorry. And let's go to the table option. So it worked. We have our force multiplier. For example, if I put 0 in there and launch a ball, as you can see here, the force multiplied with the relative velocity we set up. Oh, it was upper. The debug we set. Can't find it anymore. Yeah, right. So the force here, the log hero is what is displayed here, and it's multiplied by the force multiplier. So we have 0, and that's why the flip-up targets won't get up. So let's try 5. And as you can see, even if I hit harder, it's not enough. But we have the correct behavior, the behavior we are looking for, but we have to increase it a little bit more. Let's say 15. Alright, 15 is not enough. And let's say 25. Alright, 25 is maybe a bit too much. But as you can see, it's far faster than closing, then come back, compile again, changing the script, compile, launch the table test, and the trial and error process is quite faster. Well, we can leave it back to 55. Okay, save the option and this will be saved. But as we now have our value, we can then remove it. It was important to keep the value, the last value which was displayed. You will see why. So first, let's remove all the specifics we just used. We know that 25 is far enough. Here, replace it by 25. Okay. And just let back again. Remove this line. Okay, so now it's working for the flipup, but we have to do it also for the solenoid to kick it back. So to do it, let's copy this. Actually, we don't need any more to display it. And on the flipup target solenoid callback, we have to do that. So actually we have to test if it's not up to return, because we need for it to be up to be kicked back. And we don't have the collision value here, that's why we had to copy the magnitude of the whole multiplier, and it was around, I think, 1000. So now this should kick back when the solenoid is triggered. And the last thing we have to set up is to correctly trigger the flip-up switch at the good on the good moment. So to do that, we will modify the update statute here, the update function, which is called for each frame, and it's far enough for the switch setting. It's a rate good enough. So the only thing we have to do there is first to say that if it's up, if the up statute there is different than the current up, the last up statute, then we have to trigger the switch. So we will call set flip-up switch state, and actually we will to avoid doing it multiple times, we will set it in the temporal. So in the temporal variable, so if is up, it is up. Then in is up, we know if the flip-up target is within the margin of the up angle. And so if this value is different than the other one, the first one, we set up a new flip-up state using is up. Alright, and we have to copy it back here. First set up to recall the new state, and we have to use the table manager, actually the line we removed, it wasn't necessary. Dot and set switch, and the switch is flip-up switch slot, and we want to set it to the up value. So actually, if it just passed inside the up state, we will set the switch, and if it comes back from it, it will be correct. So it seems okay. Let's remove that. and let's just try it. Okay, and now we can try it again. Well, I just can't. Maybe I made a mistake because the M decoder is not arranged anymore. Okay, range one actually. Never mind. It seems okay. So let's launch a game to test if the flip-up target is working correctly. And launch a ball on there. Actually, it was not strong enough. Okay, seems okay for this one. Oh, lost the ball. Sure. And I try again. And it seems to be barbecue bonus is up. Okay. Seems there is some problem here with the solenoid kickback. Well. Okay, so this is working correctly. Let's play it normally. And let's lose the ball. And it should be kicked up back. Okay, so it seems to work correctly. I was making a mistake. Okay, so this is it for this video. I think in the next one we will set up the last switches we are missing. I guess it's the ramp entries, and after that we will start tuning the visual effects. Thank you for watching, and see you later, guys. Thanks.